Hi there and welcome back. In this video we show how by using PilotAware ATOM GRID we can enhance standard MODES transmissions and make them suitable for electronic conspicuity, just like ADSB.
So why is this important? In the UK, up to 12,000 GA aircraft are equipped with MODES transponders, with lots more in mainland Europe. MODES doesn't transmit GPS coordinates, so their position cannot be easily plotted on a screen. This is all about to change, and it will be incredible. Before we show you how it can now be done, we need to understand how MODES works. Ground-based radar works with MODES to get an improved view of aircraft locations. This is a typical air traffic radar transmitter and receiver, which rotates every 5 to 12 seconds. A scan rate of every 10 seconds is acceptable for normal operations. There are two parts to the system. Firstly, primary radar, which is accompanied by secondary radar, or SSR. When interrogated by SSR, the MODES transponder responds with information from the interrogated aircraft. Most importantly, this includes the unique ICAO code and the altitude. With this information, the aircraft's location can be uniquely identified, including its height and ICAO code. It's important to note that a standard MODES transmission does not provide GPS coordinates. Rather than wait to be interrogated, modern systems such as PilotAware, Flarm or ADSB transmit their unique ICAO code and GPS coordinates every 1 to 3 seconds. In this example, a PilotAware equipped aircraft receives these signals directly. This allows it to calculate the height separation, the horizontal separation and the bearing. In contrast, a standard MODES transmission is dumb until it is interrogated, and then there are no GPS coordinates transmitted. The transmissions are still received, and the vertical separation can be calculated. However, the horizontal distance can only be estimated by the rate of change of power and the sensitivity selected by the user. No bearing can be calculated at this stage. The result is that it can only be shown as a bearingless target on the screen. This is better than nothing, but it is incomplete. The answer to get the complete solution is to use multilateration. So what is multilateration? In the diagram shown, the target is the green circle. Using a minimum of 3 ground stations, the position of the MODES signal is determined. The position in the XY plane is very accurate due to the large angular distances between the stations. However, in the vertical or Z plane, this is not very accurate as the ground stations are only separated by a few hundred feet. However, this doesn't matter as the MODES transmissions contain an accurate altitude from its onboard barometric encoder. But don't just take our word for it. In Europe, multilateration is used extensively as it is very accurate. In the UK, the multilateration data is provided by 360 Radar Limited, who has access to over 1,000 stations, including the contribution from 200 ATOM GRID stations. So how does MODES 3D work? A PilotAware equipped aircraft directly picks up the MODES transmissions as seen previously, but there are no GPS coordinates. However, the ATOM GRID ground station broadcasts the ICAO codes and GPS locations of all MODES transmitting aircraft in the location. The PilotAware unit searches for an ICAO match and the correct GPS coordinates are provided. If an ICAO match is not found, the aircraft remains as a bearingless target. MODES 3D is very innovative, but needs the following understanding. Firstly, you need PilotAware in your aircraft, with the latest software. You must be in range of at least 1 ground station. There are nearly 200 stations installed. The target must be being interrogated by secondary surveillance radar, and some latency or delay will be inserted in the systems as described in the next slide. And the refresh rate must also be considered when using PilotAware MODES 3D. The first thing that needs to be considered is latency or delay. PilotAware has gathered significant data which has shown that 99% of the information is provided from target to PilotAware within 5 seconds and 61% within 2 seconds. This is very good, but the fact that there is some delay should be considered when you use PilotAware Mode S3D. The second parameter that needs to be considered is the accuracy. From the data collected, we can see that 94% of the targets are within an accuracy of 0.25 nautical miles, which is the length of 4 football pitches, or the length of a long microlight airstrip. Use the length of your runway as a yardstick to how much the accuracy will affect your flying. Finally, there is the refresh rate. The refresh rate is the time taken from one transmission to the next. This takes into account all latency and SSR interrogation rates. The information that PilotAware has gathered shows that 81% of signals are refreshed within 10 seconds. How is this all shown on the PilotAware radar screen? Firstly, a banner in the top right-hand corner shows how many ground stations you are connected to. You need to be connected to at least one station for the system to work. Mode S3D targets come with a circle of ambiguity that grows with time. The target aircraft can theoretically be anywhere in the circle. However, it is more likely to be biased towards the yellow directional lubber line. For example, the two targets have small ambiguity circles, so the delay will be a second or so. As the delay increases, so will the size of the ambiguity circle. This shows a target that has been not refreshed for a period longer than up to 10 seconds. If a target has not been refreshed for longer than 10 seconds, it will be reported as a bearingless target with height separation only. So what are the alternatives to using Mode S3D? Firstly, there is TCAS, which is both expensive and power hungry. Secondly, you could detect Mode S as a bearingless target using PilotAware or PowerFlarm. Thirdly, you can use a traditional ATC basic or radar service. If the air traffic controller is as well equipped as this chap, then it will have access to primary and secondary radar. However, if not, the controller will be limited to using binoculars and an airband radio for communications. This will result in a very high latency, low accuracy and very low refresh rate. Positional reports from in-flight pilots are notoriously inaccurate unless they are over a visual reporting point. However, whilst positional reporting using electronic conspicuity is more accurate, we always recommend that a basic service is used wherever possible. Well, that concludes this video on using PilotAware and the Atom Grid to show Mode S transmitting aircraft as a target with a GPS bearing just like ADSB. If you like the video, thumbs up and subscribe to the PilotAware channel. We look forward to seeing you next time. Fly safely and maintain a continuous external scan.